We constructed regression model y. Last week we constructed what is the model y equals about 30 or something 34 plus right. That's the model we constructed. So then ANOVA we did. Then we noted down heteroscedasticity test. Did it? Did it? Yes, heteroscedasticity test. That's what we want to note down. Heteroscedasticity test. That's the last. What is meant by heteroscedasticity? The opposite side of heteroscedasticity is homoscedasticity. When you take your residuals is what? Residuals means the difference between actual value and predicted value. Okay. Y minus Y hat. Am I correct? Yes, I am correct. Difference between Y and Y hat. When you take that graphical presentation, predicted value Y hat, actual value Y, average Y bar is difference. This is your residue. Y minus Y hat. If this residual Y minus Y hat, when you calculate the variance, if the variance of residual is constant, that is called homoscedasticity. The variance of the residual is not constant, that is called heteroscedasticity. If there is a heteroscedasticity, that is a problem in the regression model. The validity when we test in our research, in your business, you test this heteroscedasticity of your model. If the variance of the residual is constant, it's okay. Residuals are having homoscedasticity. Then good point. Otherwise, if the variance of the residual is not constant, that is the problem. It is heteroscedasticity. The reason is that if heteroscedasticity, your linear model may be changed into nonlinear model. When we construct our model, you know this is a linear one. It may be this way, whatever, it is linear. But if the model is going to change into nonlinear, that is indicated by heteroscedasticity problem. Therefore, you can't construct a linear model. You have to go for other models. Therefore, better to test heteroscedasticity in your regression model. How we do that? Different methods there to test the heteroscedasticity. We take predicted value, we take actual value, and you can calculate residuals. Right? Residuals. Absolute value of the residuals, we check with the predicted value whether they are correlated. Actual value is correlated with the predicted value. If it is not there, no heteroscedasticity problem. predicted value, then your residuals. You test the relationship. Then the significance, insignificant, based on that we take the decision. For that purpose, we use Spearman rank correlation. Spearman rank correlation. Spearman ගේ තරහ සහ සම්බන්ධතා සංගුණකය. Spearman rank correlation. Using that rank correlation, you can identify whether there is a problem or not. Right, whatever I mentioned, anything you couldn't understand. Right, step by step we want to learn. Okay, right. First write down the note, the meaning of this. Heteroscedasticity test. Visama pravichavata pariksa. Heteroscedasticity problem. Right. Now we write down. If the variance of residual is constant, the variance of residual is constant, that is called homoscedasticity. That is called homoscedasticity. Homoscedasticity. Samovichalata. Homoscedasticity. If the variance of residual is not constant, if the variance of residual is not constant, that is called heteroscedasticity. That is called heteroscedasticity. Heteroscedasticity is a problem. Heteroscedasticity is the problem. In the linear regression model. The linear regression model. This is because linear model may be not fitted. Linear model may be not fitted. Maybe not fitted to the data set. To the data set. It may be better non-linear models. It may be better non-linear models. To the data set. Therefore, to test the validity of the linear regression models. Linear regression model. Heteroscedasticity test is applied. Heteroscedasticity test is applied. Using Spearman rank correlation, Spearman rank correlation, Spearman rank correlation. Spearman rank correlation. This problem can be tested. This problem can be tested. Right. Previously, we discussed another correlation. That is, which correlation? Karl-Pearson correlation. This is Spearman rank correlation. Right? Using that, you can test Spearman rank correlation. Right. According to this Spearman rank correlation, we want to use again the steps. When you are following these steps, you can practice. Then you will become familiar. Right. Use the following steps. Use the following steps. Step 1. Define null hypothesis. Define null hypothesis. Right, null hypothesis, we write H naught, right? Homoscedasticity. Homoscedasticity. Homoscedasticity means regression model valid. Valid model. Valid model. That is null hypothesis. Samavichalata. Otherwise, variance of residual is constant. Linear model is valid. Like that. Against that, you write second step, alternative. Right. Step 2, define alternative hypothesis. Define alternative hypothesis. HA. Against that, heteroscedasticity. This means that invalid model. Invalid model. Then your confidence and significance, you decide 95% is always use. Better acceptance and rejection region. Same steps, isn't it? Right. Step 3. Decide the level of confidence or significance. Decide the level of confidence or significance. Decide the level of confidence or significance. And identify acceptance and rejection regions. Acceptance and rejection regions. When the T table is used, degrees of freedom is given by n-2. N-2. We tested Karl-Pearson similar n-2. Because you know how to take acceptance and rejection region, you are familiar. 95% means 0.475, 0.475, acceptance region. 0.025, 0.025 rejection region. Here 0 you can take from T table or Z table. Z table when you use last sample 1.96 you are familiar. Other ones you see T table take n minus. Step 4. Step 4. Calculate test statistic. Calculate test statistics. Calculate test statistics. Right, when you calculate test statistic, Spearman rank correlation we want to have. Then test statistic we use instead of R we use rho divided by 1 minus rho squared over n minus 2 squared. Right, we use test statistic. Carl Pearson we use coefficient of correlation 1 minus R squared over n minus 2 squared. Isn't it? Carl Pearson. I remember, you also remember. 1 minus R squared over n minus 2. Then R means in Spearman rank correlation, we use rho, that simple rho. Greek letter rho, right? Or you use simple R, no problem. Rho divided by 1 minus rho squared over n minus 2 squared. This is the test statistics. Ending මේකම තමයි. Right. Rho means Spearman rank correlation coefficient. Right. Coefficient of Spearman rank correlation. Rank correlation. Rho. Coefficient of correlation. But it is rank correlation. Spearman rank. How we calculate rho? This is the formula for rho. 1 minus 6 sigma d squared over n squared minus 1. That's the formula rho. Rho we calculate Spearman rank correlation using this form. One minus 6 sigma d squared. Six okay, a number of observation. D is what? D means difference of ranks. Difference of rank. Difference of ranks. Difference of ranks. Right, that is step 4. Rank correlation calculate. Then apply for test statistics. Then finally, last step. Take the conclusion. Right. Take the conclusion. Conclusion. What is the conclusion? If your test statistic belongs to acceptance region, H not accepted means almost elastic. If it belongs to rejection region, H not is rejected, sufficient evidence is there to reject. Then heteroscedasticity, it is a problem of the linear model. You can use this to a data type, data set, or you can go for nonlinear models like that. Right, conclusion we write. If test statistic belongs to acceptance region, H0 is accepted. H0 is accepted. Sufficient evidence is there to accept. H0 is accepted. Residuals are having homoscedasticity. Residuals are having homoscedasticity. Equal spread of residuals, right? Homoscedasticity. Model is valid. Model is valid. If test statistic belongs to rejection region, if test statistic belongs to rejection region, H0 is rejected. H0 is rejected. Sufficient evidence is there to reject H0. H0 is rejected. Residuals are having heteroscedasticity. Residuals are having heteroscedasticity. Model is invalid. Model is invalid. Model is invalid. Right. When you present your analysis in research, right, locally or international conferences, when you present your research papers, use these advanced techniques. Then you can say in front of the audience, variance of residual is constant. There is not heteroscedasticity problem. The model is highly valid. Then they will become happy, very, very happy. Because you have tested the validity of the model also. Do that. Right, then we want to practice in our question whether this model is valid. Do you have heteroscedasticity problem in this model? Y equals 34 plus 9x. We want to test. We did DW test, ANOVA, all this we did, right? Isn't it? We want to test heteroscedasticity as well. Okay, now take residuals and predicted values. You can do that. Okay, with me, we can start. This is my model. Okay, then we start the calculation. These 5 steps I am going to do. Right, data set here. You are having data. I need to take data again for you. There. 2, 3, 4, 5, 6. And for this data, we constructed our model y equals 34 plus 9x. We have done. We have done. Okay. Model means the predicted value. You know, why that? This is my original value y. This is my independent variable x. Okay, then I write null hypothesis, which not homoscedasticity. Alternative hypothesis that cross-cadasticity. සමවිචලතාවේ විසම ප්‍රවිචලතාව. Acceptance and rejection region, I take 95% confidence, 0.475. Acceptance region, 0 to 5, 0 to 5, rejection region. Right here, 1, 2, 3, 4, 5, 6. Pairwise 6 observation using T table. I take n minus 2 degrees of freedom. 6 minus 2, 4. We did this one in Carl Pearson correlation as well. Right, then take T table. Right, according to T table, 4 degrees of freedom, 0.025, 2.776. 2.776. Right. Then I want to calculate test statistic. Test statistic rho 1 minus rho squared n minus 2 square. To apply this formula, I need to calculate rho first. Rho I want to calculate. That is 1 minus 6 sigma d squared over n squared minus 1 I want to calculate. Then apply in this formula. Right, here we want to write down the norm. How we calculate rho? To calculate this rho, first I explain, understand, then I will provide the norm. To calculate this Spearman rank correlation rho, coefficient of correlation, we take predicted value from this model. That is, you need y hat column. Y hat column. Then you want to take residuals. In the residuals, when you take, it will become, because we can write residue, both plus and minus. There. Positive value, negative value, both there will be. Because residual means y minus y hat. Residual. Residuals there will be both positive and negative. We take absolute value of residuals. Absolute value of residuals. After calculating residuals, absolute value. Modular sign, absolute value. No need to worry about negative. Take absolute value of residuals. Here residuals means y minus y hat. Absolute value of residuals means y minus y hat absolute. Modular sign. Calculate this. Then we calculate rank correlation between predicted value and absolute value of residuals. Between these two, we want to calculate problem. Right? Right. Now write down the norm. To calculate Spearman rank correlation, to calculate Spearman rank correlation within bracket row, Spearman rank correlation. We have to calculate predicted value within bracket predicted value y at predicted value and absolute value of residuals. Absolute value of residuals within bracket y minus y hat absolute value modular sign. Know the modular sign. Modular sign. Modular sign. Absolute value. No need to worry about negative. Right? We have to calculate absolute value of this. This one, right? After that, calculate rank correlation. After that, calculate rank correlation. After that, calculate rank correlation. Row, right? We want to calculate. Right, with me, take first this one. First take y hat. Model is, I write model here, y hat 34 plus 19. Right, now take y hat column. It is easy, we have done. Right, previously also we did last week. First, when you substitute 2, y hat 34 plus 9 into 2, 34 plus 18, 12, 52. You are having these values. You are having. Last week we calculated these values. Then second one, substitute 3. 9 into 3, 27, 61. 61. You did this. Then substitute 4. 34 plus 9 into 4, 36. 10, 6, 7, 70. 5. 34 plus 9 into 5, 45. 9, 79. Then 6, 54. 34 plus 54. 8, 88. These figures you calculated last week, isn't it? You are having. If the last week not is with you, you are having. I don't know whether they are at home. Right. Y hat you are. No. Then I want to calculate absolute value of residuals. Take absolute value of residuals. I take first y minus y hat first I take. It may be both plus and minus. First one, y50, y hat 52 minus 2. This is also victim. Make up the elastic calculator. DW test. When you calculate Derwin-Watson test, you are having, isn't it? Got it. Right, you know. 60 minus 61 minus 1. 60 minus 70 minus 10. 80 minus 70 plus 10. 90 minus 79, 11. 80 minus 88 minus 8. Breathing on it. Then you want a absolute value. Absolute value. Y minus y hat absolute value. This is residual. This is absolute value of residual. මේ තියෙන්නේ දෝෂේ, මේ තියෙන්නේ දෝෂේ නිරපේක්ෂක. Absolute value of residuals. Really understand? If you couldn't understand, please ask. I explain again and again. Absolute value means no need to worry about minus 10, 10, 11, 8. Absolute value means no negative value. Irrespective of negative, we take absolute value. Nirapeksa. Right. Then I can apply this one. This formula. How I calculate? I take space here. First, I want to take rank y hat rank. D is what? Difference of the rank. Rank one. Difference of the rank. Then I want to rank y hat and absolute value of residual. I want to rank. Minimum value 1, next minimum value 2, next minimum value 3. Like that, I want to rank. Right. Then under that, write down further. D. 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 This represents difference of the ranks between predicted value and absolute value of residuals. Predicted value and absolute value of residuals. Initially, we want to rank y hat and absolute value of residuals. Absolute value of residuals. Initially, we want to rank y hat and absolute value of residuals. The difference is denoted by simple D. The difference is denoted by simple D. Right. But when you take squared, irrespective of the negative, it will become positive. Right. Now I want to rank. First take with me y rank. Y hat rank. Y hat rank. Rank. Y hat rank. Now y hat take rank from there. I'm going to rank y hat, predicted value. Check. What is the minimum? 52. Number, order 1. Rank is order 1. What is the next minimum? 61. 2. What is the next? 72 times. Then already we have assigned 1 and 2. Then 2 numbers means 2 ranks. 3 plus 4 divided by 2. 7 divided by 2 means 3.5. Assign 3.5 to this one. Again, the similar value 3.5. If there are 3 numbers, add all these divided by 3. Assign 4. Okay. Order 1, order 2. But you can't order 3, 4. Why? Because same numbers. Then 3, 4, both you add divided by 2. Then assign similar value, similar rank, 3.5 and 3.5. Okay. Similar. Yeah. Yeah, similar numbers. Then 3, 4, 5 and divided by 3. Assign 4, all the same numbers, same rank. The next number is 79. Already we have assigned 3 and 4. Next one is 5. Then next one is 6. Likewise, according to Z score also, the students are ordered. Same Z score, then the rank, assign same rank for all. What am I come rank today? Equal Z score. Right after that, all the ranks 3, 4, 5, 6 like that. If the students there, we skip that rank, take from the next. Similar. Right, this is the y hat rank, predicted value rank. Then I go to rank this one, absolute value of residual. Right. Y minus y hat absolute value rank. Rank. Right, what is the minimum value? 1. Next one, 2. First one, second one. Then third one, 3. Then same numbers. Already we have assigned 1, 2, 3. Then 4, 5. 4 plus 5, 9. 9 divided by 2, 4.5. 4.5. Then next one, 6. Clear the rank? Y hat rank, absolute value of residual rank. Now I take D, this one, difference of rank, difference of rank. Now I clear this, I want to take difference of rank, equals to keep this space, D. D means Y hat rank subtract Y minus Y hat residual rank. That difference, this difference. Y hat rank, Y minus Y hat rank. But at the same time, take square. No need to take another column, take square. Then don't worry about negative value. 1 minus 2, but minus 1, but don't worry because it's square, plus 1. 2 minus 1, 1 is square, 1. 3.5 minus 4.5, 1 is squared, 1. 3.5, 4.5, 1 is squared, 1. 5 minus 6, 1 is squared, 1. 6 minus 3, 3 squared, 9. Now take sigma d squared. Sigma d squared. 9, 10, 11, 12, 13, 14. 14. Okay. The square of the rank difference, summation of the square of the rank difference is 14. Right. Now apply the formula to take rho. Now I take rho 1 minus 6 multiplied by sigma d squared 14 over in means 6 squared minus 1. This is my rho value. This is my rho value. Point 6. 0.6. Rank correlation rho is 0.6. Then you can calculate test statistics. Right, and clear this side. Test statistic rho 0.6 divided by 1 minus 0.6 squared over 6 minus 2 square root. That is my test statistics. One point five. This issue is started within some of those. 1.5. Now take the decision. This belongs to acceptance rate. You obtain this part higher, relationship will be negative. Right. Your decision, test statistic acceptance region H not accepted, homoscedasticity. Model is valid model. Now we write test statistic belongs to acceptance region. Test statistic belongs to acceptance region. Residuals are having homoscedasticity. Residuals are having homoscedasticity. Model is valid. Model is valid. Right, like that you can test. And that is the advanced part you learn for heteroscedasticity test. I use experiment rank correlation to take the decision, but there are more methods, right? Those methods, another method is the Bush-Fagan-Godfrey heteroscedasticity test. Bush-Fagan-Godfrey. Another one, White heteroscedasticity test. But experiment rank correlation test, heteroscedasticity we test. But if you want to study those techniques, please after the examination call me, I will teach. Within this time frame, you have to learn only this. No need that for free. Those tests are not included in your syllabus. Right. Then I think the second question, you can test all of these. Second question. Coefficient of correlation, then regression ANOVA table, model summary, R squared, adjusted R squared, DW test, multiple correlation, and heteroscedasticity test. Coefficient of correlation, Carl Pearson we did. Then constructed regression model. Y hat. Then we constructed regression ANOVA table and statistics. Then constructed R squared, R bar squared, DW test, and multiple correlation R. Today we discuss heteroscedasticity test. Complete. Then practice the second question also all these. And another assignment, I think that it has been sent to practice like this. Right, then all these we can calculate again in the multiple regression model as well. Multiple regression model. We want to practice that. Right, now we take multiple regression model. Second question you can practice now. Was X, Y. X and Y. What is the model you constructed at home? What is the model you have taken? Look at that. Either the other modeling in Qatar. Right. Either is in other, right? Right. Now we start multiple regression model. This question because more than one independent variables. Right. Now we take multiple regression model. Multiple. Bahuguna pratipayana. Multiple regression models. Right. Practice that second question. I will send the answer of this question by next week. Then you can practice. Right. Practice means before my answer, you practice. මම answer ගෙවන්න කලින් practice කරා. නැත්නම් මම ඊවට පස්සේ practice කරාට වඩා. ඒකමනේ. නේ. You copy and paste. Right. Multiple regression model means more than one independent variable. First, one dependent variable. More than one independent variables. Right. Now we write down the meaning. If we have more independent variables, we have more independent variables. In the regression model, that is a multiple regression model. If you have more independent variables in the regression model, that is a multiple regression model. That is a multiple regression model. we have to calculate intercept and individual beta values. Slope. Individual beta values of each independent variable. Each independent variable. Using ordinary least square method, same method. Using ordinary least square method, OLS. Using ordinary least square method, model is constructed. Model is constructed. Because your model will be like this: y equals beta 0 plus beta 1 x1, beta 2 x2, beta 3 x3. Like that, the model. Beta n xn. That's the model. This is your intercept. You are having data. Dependent variable, independent variables, you are having data. But your objective to calculate intercept, content, and individual beta values. Individual beta values. Beta values. That is slope. Slope. Anupramani, gradient. You need to calculate. Right, the standard model we write like this. Right, this is the model. Right, then write down model. Model is given below. Model is given below. Right, y equals beta 0. Right. Intercept and beta values. This is also beta value. Intercept. One. Each independent variable, there is a coefficient. Right. When we construct that regression model, OLS method means all the steps what we followed previously. Same steps. But steps we want to continue because of more independent variables. More independent variables. Right. Now continue. Using following steps. Multiple regression model can be constructed. Multiple regression model can be constructed. Step one. Write the model using X and Y. Write the model using X and Y. Y means this Y. Using X and Y. Right. That is this one. And step one is this. පළවෙනි පියවර මේක ලියන්න. Step 2. Apply sigma notation. Apply sigma notation. Apply sigma notation to the model. To the model. We receive මොකක්ද හම්බෙන්නේ? Normal equation 1. Normal equation 1. We receive normal equation 1. ප්‍රමත සමීකරණය කාම වෙනවනේ. We receive normal equation 1. දාන්න සිග්මා බලන්න. ඔකට sigma knowledge එක දැන් තුනම තියෙනවා. Right. You have very powerful sigma knowledge. Sigma notation we learned last week. Also we did sigma. Y sigma y. Beta 0. No variable, constant. Instead of sigma, n beta 0. Beta 1 with variable. This is the coefficient. Coefficient is taken out. Beta 1 sigma x1. Beta 2 x2. Beta 2 sigma x2 plus beta 3 sigma x3. Beta n sigma xn. Normal equation 1. Normal equation 1. We apply sigma. Sigma notation we learned at the beginning before starting the calculation. Before starting analysis, we did sigma. Isn't it? After the data presentation. Data organizing, data presentation, then we learn sigma notation. After that, we went to descriptive statistics, central tendency. Sigma notation, හොඳට මොකද දැනගෙන තියෙනවා. මම කියවනේ sigma notation මම මෙතනදී ගන්නවා කියලා regression model වලට. එන්න කිව්වා. ඔයගොල්ලෝ එතෙන්දී කිව්වේ කමන්නේ ඔයා ගන්න කියලා. Right. That's why apply sigma. That is step 2. Then is step 3. Step 3. Step 3, you have independent variable first form. All model only one independent variable. The first independent variable you multiply your model, this model, then apply sigma notation, you receive normal equation 2. Then normal equation 2 will come up. Then multiply it by x2 and apply sigma notation, normal equation 3. Continue all the independent variables, multiply and apply sigma, multiply and apply sigma, you receive normal equations gradually. Right? Normal equations. That is step 3. Multiply the model by independent variable 1. By independent variable 1. That is x1. Within bracket x1. Multiply the model by independent variable 1 within bracket x1. And then apply sigma notation. Then apply sigma notation. we receive normal equation 2. We receive normal equation 2. Right, now do that. Number I multiply by x1. x1 I multiply. x1 by beta 0 x1 beta 1 x1 squared beta 2 x1 x2 beta 3 x1 x3 beta n x1 xn. x1 के වැඩි කරනවා. බීජීය ප්‍රකාශනය වැඩි කරන්න. algebraic expressions you have done. Next one, I multiplied by x1. Come on. Then apply sigma. Then apply sigma.
X1,
Beta 1, x1.
X1.
Yeah, x1, that is x1 multiplied by x1 means x1 is squared. Okay, x1 into x1, that is x1 squared. Then apply sigma variable sigma x1 y beta 0 sigma x1 beta 1 sigma x1 squared beta 2 sigma x1 x2 beta 3 sigma x1 x3 beta n sigma x1 xn. That is normal equation 2. Very interesting, isn't it? Because in your business, how many variables you have? Thousands of variables you can apply if you know these steps. My steps one variable but apply. Therefore, you won't understand these steps. Clearly understand. Multiply x1 and then apply sigma. When you apply sigma, sigma notation. Only constant n. Coefficient with variable, coefficient is taken out, apply sigma to the variable. If you have constant a, sigma, n, x, a is out, sigma x, xy, try that, sigma xy. Your sigma notation, we learn 5 rules. Rule පහක් study කරේ. අන්නේ rule පහකින්. එච්චරයි. Very simple things. Oh, සරල දෙයක් තියෙන්නේ. If you keep in mind that sigma notation is very simple. Right, then you multiply by x2, apply sigma. Then x3, apply sigma. x4, apply sigma. x5, apply sigma. Like that, continue all the independent variables. This is step 3. My step 3 එක සෑම variable එකටම ඔක්කොමයි කරන්නේ. Continue. Then you obtain normal equation further and further. Two independent variables. x1 you obtain only other steps. x2. 3 variable, another steps. 4 variables, another steps. Like that, you have to continue for all the independent variables. Right, then we write step 4. Continue the step 3. Continue the step 3. continue the step 3 for all the independent variables. For all the independent variables. Right. If you use to x2, I will show x2 also. What happens if I multiply by x2? What would happen? Then x2y, right? Beta 0 x2. Beta 1 x1 x2. Beta 2 x2 square. Beta 3 x2 x3 plus beta n x2 xn. x2 එක වැඩි කරන්න ඕකනේ වෙන්නේ. Then sigma knowledge එක තියෙනවා. You have sigma notation. Apply sigma. Sigma x2y. Beta 0 out, sigma x2. Beta 1 out, sigma x1 x2. Beta 2 out, sigma x2 square. Beta 3, sigma x2 x3. Beta n, sigma x2 xn. That is your normal equation 3. ඔය දෙක හම් වෙනවා ඒ equation variable ගන්න. Another variable. The organization, there may be more independent variables. Models should be continued. Normal equations should be continued according to the number of independent variables. 2 variables, you finish problems. Okay. n වලින් වැඩි කරන්න මොකද වෙන්නේ? xn y. Beta 0 xn. Beta 1 x1 xn. Beta 2 x2 xn. Beta 3 x3 xn plus beta n xn square. හරි නේද? දැන් මොඩල් එක පේනවා වගේ. xn වලින් වැඩි කරන්න. xn වලින් මේක වැඩි කරොත් ඒකනේ වෙන්නේ. ඊට පස්සේ sigma දාන්න. Right. When you continue for all the independent variables like that, you can find, right? x2, x3, x4, x5, you do. Then, next step, for all these normal equations, you want to take data. Necessary data you want to take from the data set. Then they will become simultaneous equations. Samagama samikana. Right. Next step, we write down. Take necessary data. Take necessary data for normal equations. For normal equations from the data set. From the data set. Then they will become simultaneous equations. Then they will become simultaneous equations. Right, they will become simultaneous equations. Finally, the simultaneous equations, when you solve, you can obtain the set and all these beta values. Right. Then last step, solve simultaneous equations. Solve simultaneous equations to obtain intercept and solve simultaneous equations to obtain intercept and individual beta values. individual beta values. Individual beta values of all the independent variables. Individual beta values of all the independent variables. Right, now practice this question. Practice this question. One company needs your help to identify the sensitivity of the price and demand, price and income or demand of a particular product. The following information is provided here. Price there, income in 10,000, demand in 5 data points. Price, one variable, income, another variable, demand, dependent variable. Then 2 independent variables. Based on that, you can consider multiple regression model. Right. Now write your multiple regression model. Right, do that. Right. Now write the model. Two independent variables means you want to finish from 2 independent variables. Section 30 repeat plan. Write 2 independent variables. Model y equals beta 0, beta 1 x1, beta 2 x2. Even though you write like this, no problem. Y equals a plus beta 1 x1, beta 2 x2. No problem, right? We use y equals a plus bx. Right? Beta 1 x1, beta 2 x2. Y means demand. X means x1 is price. This is price. This is income. That not wording when you write x1 price, x2 income, respectively, I use. Right, that's the model. I need sigma. Normal equation 1. Sigma y in beta 0, beta 1, sigma x1, beta 2, sigma x2. Normal equation 1. Normal equation 1. Initially, you apply sigma. Right, then I multiply by x1 and apply sigma. Step 3, multiply by x1. When I multiply by x1 by beta 0 x1, beta 1 x1 squared, beta 2 x1 x2. Then apply sigma. Variable, prior to the variable, I apply sigma. Coefficient, take it out, apply to variable. Sigma is applied to variable only. Beta 1 sigma x1 squared, beta 2 sigma x1 x2. Second normal equation. Then next step, you have to follow this. Another variable is there. X2. When I multiply x2y, beta 0 x2, beta 1 x1 x2, beta 2 x2 square. Then apply sigma. Sigma x2y, beta 0 sigma x2, beta 1 sigma x1 x2 plus beta 2 sigma x2 square. Third normal equation. Right, now I want to take necessary data from the data set. Step 4. Step 5. Take necessary data for normal equations of one, second one, and third one from my data set. I want to take. Right, now I write these normal equations, write my data set here. Sigma y first equation I write 10 beta 0 1 beta 0 beta 1 sigma x1 beta 2 sigma x2 first equation. Then second, you don't want to write like this, right? X1 y beta 0 sigma x1 beta 1 sigma x1 squared beta 2 sigma x1 x2. Second equation. The third one is y write down sigma x2y equals beta 0 sigma x2 plus beta 1 sigma x1 x2 beta 2 sigma x2 squared. Right, these three equations I got separately because I want to take my data set here. Right, from the data set, I take price as x1, income as x2, demand as y. Data 98967 453 7 and 8. Demand 40 50 30. Right, from the data set, you can obtain values. Necessary data for the normal equations. Right, we developed simultaneous equation before the break. First one, sigma y, summation of this column. 0, 12, 15, 20, 24, 240. Sigma y. And we know all these three 1, 2, 3, 4, 5. 5 data points. Not 15, right? 5. Right, sigma y 240. N is 5 beta 0. Now I want to take sigma x1. Summation of this column sigma x1 9 17 9 18 20 26 26 30 32 39. 39. Right. 39 beta 1. Then sigma x2, summation of the column 8, 15, 20, 24, 27. 27 beta 2 simultaneous equation 1. Right, do all these calculations like that. At first we take simultaneous equations, then we take the break. Take simultaneous equations. No, break is required before the simultaneous equation. Right. Sigma x1 y, x1 multiplied by y. I take space here. X1 y. 9 into 40, 360, 8, 5, 400, 9 into 20, 27, 270, 36, 360, 76, 42, 112. Sigma x1 y 0, 6, 8, 15, 51, 11, 4, 7, 9, 11, 18, 7. 1, 8, 1, 0. Till this one, 1, 8, 1, 0. Sigma x1 already you have calculated 39 beta 0. Then next sigma x1 is squared. Another column. 9 squared 81, 64, 81, 36, 7 squared 49. Sigma x1 is squared. 5, 6, 12, 12, 9, 21, left 4, 7, 9, 17, 17, 25, 30, 31. 311. Right. 311 beta 1. Sigma x1 x2. Multiply. Take the calculator, then you can do 9, 336, 40, 27, 42, 56. Sigma x1 x2. 30, 19, 21, to left, 5, 9, 11, 13, 13, 17, 20, 201. 201 beta 2. Second simultaneous equations. Then third one, sigma x2 y. X2 multiplied by y. 0.40, 160, by 250, 90, 20, 0.80. Sigma x2y 0, 8, 10, 19, 20, 24, 30, 3 left, 4, 7, 4, 8, 11, 4, 6, 1,400, 1,400. Beta 0 sigma x2 already you have calculated sigma x2 27 beta 0. Sigma x1 x2 you have done 201 beta 1. Sigma x2 is squared unit. Take another column x2 squared. Y squared 16, 25, 9, 49, 64. Sigma x2 square. 5, 9, 13, 20, 22, 28, 30, 33, 3 left. 6, 10, 13, 16. 163. Right. 163 beta 2. Three simultaneous equations. Right. Simultaneous equations, when you solve, you can obtain beta 0, beta 1, beta 2. Then your model will be finished. Model will be finished. You need to calculate what is the value for beta 0, beta 1, and beta 2. Using your calculator, scientific calculator, when you do in equation mod, you can find this. Beta 0 means x, beta 1 is y, beta 2 is z. Calculator provides like that. Right. After the break, we solve these simultaneous equations using calculators. Right. Take the break and come. Oh, negative. Beta one beta value itu negatif. Oke, mungkin jadi pastikan oh, beta variable negatif. Harus. Formula sheet tego, formula sheet tego. Oh, formula sheet টা করে টাচ করো। Formula sheet টা না tapasnya nah lagi. Formula attach করো। Guys, tables guys, oh. Right. Okay, shall we solve simultaneous equation? Use your calculator to solve these three simultaneous equations. In your equation mode, MS calculators, you can see unknown 3. Unknown 3 means simultaneous equation 3. At ES calculators, when you use the mode key, equation mode, then option 2. 2 means three simultaneous equation AX, BY, CZ, DN. You can see like that. Right. Option 2. Then as a matrix, you can see A, B, C, D. It means that ES calculators, this is A, this is B, this is C, this is D. MS calculator A1 means is 5, B1 39, C1 27, D1 means 240. First equation. Right, now I enter data. A means 5 equals 39 equals 27 equals 240 equal. It comes in second. 39 equal 311 equal 201 equal 1810 equal. Right, if there is a problem, please ask. 27 201 163 1,400. I entered all these data. Then equal sign. Calculator provides answer 45 as X. That is my beta 0. Then equal sign provides minus 2.74. 74. Again equal sign is at 4.51. X, Y, Z. Okay. Any problem in your calculator, please inform me. Any problem to operate your calculator? Right. Yeah. Okay, next calculator. Okay. Number one. Okay, then I can write my model. Because we are not expecting to solve this simultaneous equation manually, right? You are aware, but no need to spend more time. Then write your model y equals 45 minus 2.74 x1, 4.51 x2. In wording, y means demand equals 45 is the constant term minus 2.74 x1 price plus 4.51 x2 income. Come on. For this data, we constructed this model. When you interpret what you can say, when the price is 0, income 0, demand will be 40, right? Demand, we can see like that, demand 45. That is a constant term. But the important is not the constant term, these two beta values. Price has a negative effect on demand. High price, less demand, less price, high demand. Agree with demand theory. Income has positive effect on demand. High income, high demand, less income, less demand. Agree with income theory, Keynesian consumption theory. Agree, isn't it? So then your interpretation, when the 1 unit of price is changed, demand will be changed by 2.74 units negative. When the income is changed by 1 unit, demand will be changed by 4.51 units positive. That's the interpretation. Okay, right. Now we write interpretation like this. According to the model, constant term is 45. Constant term is 45. This means that when the price and income are zero, when the price and income are zero, this means that when the price and income are zero, demand will be 45. Demand will be 45. Beta value of price is minus 2.74. Minus 2.74. This means that when the price is changed by 1 unit, the price will be rupees or dollar or whatever. When the price is changed by 1 unit, demand will be changed by 2.74 units. 2.74 units negative. Beta value of income is 4.51. 4.51. This means that when the income is changed by 1 unit, demand will be changed by 4.51 units. 4.51 units positively. Right. Therefore, beta values may be both positive, negative. Correlation may be positive, negative. Negative means when the value of one variable goes up, the value of another variable comes down. Negative relationship. Right here, negative effect price, positive effect income. Then you can forecast. Right. Now write down this one. Forecast the demand. If the price is 10 rupees, and income is 90,000 rupees. 90,000 rupees. Right. Price is 10 rupees. Income 90,000 rupees. But the model income 10,000. 4 zeros we cut. 4 means 40,000. Therefore, 4 zeros to cut. Then substitute in the model 9. Right. Substitute 10 and 9, then you can forecast your demand. I forecast my demand here. Y Y 45 minus 2.74, price is 10 rupees, plus 4.51 multiplied by 9. 9 means 90,000 rupees. This is my forecasted demand. $58.19. This is 58.19. That's the demand. Demand forecast. Right. Now in this model, you can construct regression ANOVA, R-squared, adjusted R-squared, David Watson, all this you can do. Right. Multiple correlation. Then a table pane over again. Model is there. Right. Now construct regression ANOVA. Regression ANOVA. Right. I take my model here, take this space. Y equals 45 minus 2.7.1, 4.51, x2. This Y means actually this is forecasted predicted Y hat. Y hat. This is your Y hat model. Is it? Predicted model. Predicted model. Right. Now I am going to take my regression ANOVA. I test regression ANOVA. H0 I write. Model is jointly invalid, not appropriate, insignificant. All the terms we learn. Alternative hypothesis. Model is jointly significant, jointly valid, like jointly valid. Significant, appropriate. Otherwise, here model is not appropriate, here model is appropriate. Then F distribution, acceptance region 0.95, rejection region 0.05, F distribution, acceptance region, rejection region. Later we take this critical value after we identify ANOVA table. Now I take next one, ANOVA F test statistic. So this is your step 1 null hypothesis, step 2 alternative hypothesis, acceptance and rejection gradient from a distribution. Step 4, calculate F test statistic, F test statistics. F test statistic is regression ANOVA table. Isn't it? Right here, model sum of square, degrees of freedom, mean square, F statistic. First row regression, second row residual, third row total. These three rows. Right, regression ANOVA table. Sum of square of total equals sum of square of regression plus sum of square residual. That's it. Two values if you calculate, the balance you can take. They can't calculate. But before that, we calculated all these three. Here, calculate two figures. At the exam, you calculate two figures. In the business also, you can apply for the data two figures. Then balance you can take. Right, now I calculate SST. SST means sigma phi minus phi bar square. Next. SS regression means sigma y hat minus phi bar square. SS residual means sigma y minus phi hat square. Yeah, graphic पेनों की नजर निकाल इमेजिंग करने पे graphic y पेनों आगे नहीं total means y minus y bar everything powered y hat minus y bar unexplained y minus y hat टक्कर बहुत तो बोलने को भी बोले नहीं अरे नहीं ग्राफिक पे टक्कर है इधर kan फिर मैं द्वार कैलकुलेशन में क्या भी क्रम Right, two figures if you calculate the balance you can take. I take y minus y bar. Right, I delete these to take the space. हमें Wednesday read कर आइना spacing कर. Right, y is the value. Y bar. I won't take y bar. Sigma y over n. Sigma y 240 divided by 5. 5, 1, 2, 3, 4, 5. Then 4, 20, 44. 48. 20, 40 means 8. 48. Then calculate this part. Y minus y minus y bar square. I calculate SST bar. SST. Y minus y bar square. Y40 minus 48 square. 8 squared, 64. 50 minus 48 squared, that is 2 squared, 4. 30 minus 48 squared. 18 squared, 320. 324, no? 80, 864, right? 60 minus 48 squared, that is 12, 140. 60 minus 48 squared, 140. Now take the summation of that. 64 plus 680. Sigma y minus y bar square 680. Right, 680 sum of this total variance 680. By y you obtain 40. Right, degrees of freedom write down. Degrees of freedom in the total is given by n minus 1. 5 minus 1, 4 degrees of freedom. 4 degrees of freedom. Okay.
So degree of freedom is n minus 1.
N minus 1 here. Degrees of freedom total. Right, SST finish. Right, one of these two calculate. When they get covered, y bar we have 48. Now I calculate y hat. Y hat is my model. I want to take y hat x1 9, x2 4. What is y hat? Then second y hat x1 8, x2 5. Substitute and simplify. Right now I do use in the calculator 45 minus 2.74. 2.74 multiplied by 9 plus 4.51 multiplied by 4. That is my income, right? Then 38.38. I take 2 decimal point, 1 decimal points. Or 2 decimal points if you want, 30.38. 38.3. Twice 38.4. Like that, 1 decimal. Can be solved. Right, then second 45 minus 2.74 multiplied by x1 8. Use the bracket and take 4.51 multiplied by 5. 45.63. Next one, 45 minus open bracket 2.74 multiplied by 9 plus 4.51 multiplied by 3. 33.87. Next, 45 minus 2.74 multiplied by 6 plus 4.51 multiplied by 7. 60.1 plus 45 minus 2.74 multiplied by 7 plus 4.51 multiplied by 8. 61.90. Y hat. Then sum of its regression y hat minus y bar. Calculate y hat minus y bar is calculated. Y hat 38.38. Y bar we calculated 48. 48 is calculated. Next. Take that. 45.63 minus 48 is square. 33.87 minus 48 is square. 60.13 minus 48 is square. 61.90 minus 48 is square. That is the explained variance. Right. Now I calculate 38.38 minus 48. Then is square of that 92.54. I take 2 decimal points. 5444 like that. Right. 45.63 minus 48. Square of that 5.616. Therefore, I take 5.62. 2 decimal point. 5 or more. Take to next round figure. 33.87 minus 48. Then take the square of that. 199.656. Therefore, 66. 60.13 minus 48. Then the square of that. 147.136. 147.14. 2 decimal points. 61.9 minus 48. Square of that 193.21. Now take summation of that. That is sigma y hat minus y bar square. But if you learn that theory part, calculation is easy. 54 plus 5.62 plus 199.66. 147.14 plus 193.21 plus 638. 638.17. In here I write 638.17. Sum of which are regression. At the same time, you can take 680 minus 638.17. Right, 680 subtract that value 40 was 0.8. Right. Now degrees of freedom right here, how much? How much? Degrees of freedom regression? Yes. 2. Number of independent variables. Because here degrees of freedom is given by k number of independent variables. 2. Here 4 minus 2, 2 residual. That is degrees of freedom n minus k minus 1. Isn't it? N is 5, k is 2 minus 1. 5 minus 3 again. දෙකක් calculate කරන්නේ දෙකක් ගන්න. Right. Now take mean square. Mean square, sum of square divided by degrees of freedom. 638.17 divided by 2 degrees of freedom, 319.085. I take 09. Approximately 2 decimal point. 0.85. Therefore, I got 09. Right, 41.83 divided by 2, 20.915. Then I take 2 decimal point, 20.92. Right. Then F statistic. F statistic means some mean square regression divided by mean square residual. Right, 319.09 divided by 20.92. If you use 3 decimal points, take that. Right, 15.252, yeah, 15.25. 15.25. Clear? Now take this critical value, acceptance and rejection rate. F distribution, numerator degrees of freedom means degrees of freedom regression. Denominator degrees of freedom means degrees of freedom residual. Regression, residual, degrees of freedom 2 and 2. 2 and 2. Then F table 2 and 2. Here 2, here 2. 19. 2 degrees of freedom, 2 degrees of freedom. Regression and residual. Isn't it? It's 38.17 divided by 2, this value. This value divided by this one. F statistic means 319.09 divided by 20.92, this value.
How do you get that two side? Degree of one. N minus k, but the
K is number of independent variables. Number of independent variable, price, income, two independent variables. Degrees of freedom, K. Plastic is not a number, K. Degrees of freedom. Now take the decision. What is your decision? F statistic belongs to where? Acceptance region or rejection region? Acceptance region or rejection region? Who has not covered? F statistic belongs to acceptance region. Then model is jointly invariant. Model එක එච්චර හොඳ නැහැ. එහෙනම් data ටික වැඩි කරන්න. Right? Model is not appropriate. එමේ data points කීපයක් තියෙනකින්ද වෙන්නේ. ඕලා. Okay. Degrees of freedom can be increased if you have more data. Right, then you can take good model. Right, but according to that, we want to interpret. Then we write down a degrees of freedom. Will be there. කියන්නේ degrees of freedom regression තමයි මෙතන degrees of freedom residual තමයි මෙතන numerator denominator කියලා මේකේ අපි ඔය ලියාගත්තේ ඒකයි numerator degrees of freedom between groups regression so degrees of freedom denominator within groups residual මේ දෙකකින් ගන්න right. Right, now we write interpretation. F test is statistic. F test is statistic. Belongs to acceptance region. F test is statistic. Belongs to acceptance region. F test is statistic. Belongs to acceptance region. H naught is accepted. H naught is accepted. It means that no sufficient evidence to reject H naught. H naught is accepted. Therefore, model is jointly invalid. Model is jointly invalid. Within brackets, not appropriate model. Not appropriate model. Right, then what you can do, you can increase this data point. The point is this කරන්න හරියන්නේ. Right? Data points වැඩි කරන්න හොඳයි. වැඩි කරන්න මේ විදුව ගණනාපේ වැඩි කරන්න යන්න එපා. Right? From your business you can take data. Okay? Right, therefore take star mark. When we increase the data points, this problem can be addressed. Because in your organization, you can collect more data. Then you can do it. But to practice, we use. Right. If you are having this regression ANOVA, calculate other figures. R squared, adjusted R squared, multiple correlation, Durbin-Watson test. Right. First calculate R squared, multiple correlation. R squared. Sum of square of regression divided by sum of square of torsion. Isn't it? 638.17 divided by 680. 638.17 divided by 680. 0.938. Ninety-three point 8% of your dependent variable, that is demand, has been covered by this model. Theater anu tunai this model එක cover කරලා තියෙනවා. Demand. Nicely fitted model. But the problem, no one is not appropriate. මේක කොච්චර වුණත් මෙයා හොඳ නැත්තම් මොඩල් එක පාවිච්චි කරන්න යන්න. data වැඩි කරලා. Right? But for understanding, we want to write this. Right, now write down according to R squared, 93.8%, 93.8%, 93.8% of demand has been explained by the model. Model is nicely fitted. Nicely fitted කියලා ගත්තේ මොකද්ද value එක? 0.6 or more. 60% or more nicely fitted model. Point 6 or more. Right. But you have to keep in mind and make it even though R squared is appropriate, even though R squared is high, ANOVA is not appropriate. We do not use the models in our business. The data වැඩි කරන්න, outcome එකක් වැඩි කරන්න. Data points. Okay. The beta values are little bit maybe changed its value, then you can forecast it better. Right, but to understand 93.8%, right? Calculate adjusted R square, R bar square. Adjusted R square, R bar square, 1 minus R square, n minus 1 over n minus k minus 1. Right? One minus R square 0.938. Here data points 5 minus n is 5 minus 1, n minus k, 5 minus 2 minus 1. One minus 0.938. 5 minus 1, 4. Here 2. Zero point 876. Right, then interpret. 87.6% of demand has been explained by the model. Right, now we write. According to R bar square, 1 minus. It is 1.3, 1 minus 0.98.
1.8.
1 point. No, it cannot be. 1 minus 0.938, 1 minus 0.938. Then that value should be divided, multiplied by 4 over 2 means 2. Then 1 subtract the answer. 0.876. Instead of making make out of it, this part. Right now we write down according to R bar square. 87.6%. 87.6% of demand. 87.6% of demand has been explained by the regression model. Has been explained by the regression model. Right. Calculate multiple correlations are square root of R square. That is 0.938 square root. Square root of 0.938, 0.968. Strongly jointly correlate. X1, X2, price and income is strongly jointly correlated with demand. Correlation is high. Correlation is there. Multiple correlation. Multiple correlation. Multiple correlation. Taking of multiple correlation. How independent variables jointly correlate. That make it multiple correlation or multiple regression model. Right. Now we write down independent variables are strongly jointly correlated. Independent variables are strongly jointly correlated with the dependent variable. This means that price and income are strongly jointly correlated with demand. Demand is strongly jointly correlated. Right. Now calculate Durbin-Watson test. Durbin-Watson. DW test. I need residual. Residual I need. Then residual I minus 1 I need. Because DW test sigma residual of I, the previous residual square divided by sigma residual of I square. Right, residual means you are having y value. I write here residual y minus y hat. Residual y minus y hat. Residual here. When a y hat. When a y and when a difference again name y minus y hat. Finally y hat at all. This means that y minus y hat. One more that. Right, first point. Y40, Y at 38.38, 1.62. Calculate. Y50 minus 45.63, 4.37. Next one. 30 minus 33.87 minus 3.87. Next one. Y60, Y at 60.13 minus 0.13. Next one. 60 minus 61.90 minus 1.9. That is residual. I need to take Ri residual. Ri minus 1. Ri minus 1 means previous residual. Then current residual. First point blank. We don't have. Right. Next one previous. You can take 1.62. Next one previous 4.37. This one previous minus 3.87. This one the previous minus 0.1. Calling it. Then R minus 1. Time period dekha T make a T minus 1. Theos. Independence and dependence of residual we test. Right, then here I calculate residual of I minus residual of I minus 1 squared into that. First point that. Right, 4.37 minus 1.62 squared of that 7.56. Next one. Minus 3.87 minus sign, your calculator, you can take minus sign is there. Subtract 4.37. Then square of that 67.89. 67.89 or 67.90 you can take. Minus 0.13 subtract 3.87. Square of that 60